So in this case, we are going to be looking into question number 9, which is actually on our transformation, where we are given, that was question number 9, answer the whole of this question. Whatever that we are given there, it is supposed to be done on a sheet of graph paper. So that was our instruction for this question. So we're not going to waste much time. Quickly just try to figure out how are we supposed to attempt such typical questions of transformation. So we were told here to use, that is using a scale of 2 centimeters to represent 1 unit. So whatever that we are given there, it is 1 unit on both axes. Given the interval for x and also the interval for y, draw the x and y axis. Okay, so let us figure out, as we can see, the x is positive. These are positive values, guys, from 0 to 7. We only have positive values. And the y values from -4 up to +4. So we're just going to try to have as it is. So meaning to say, we have got the x. Remember, the x is not affected. We need that one from the 0. So this is our x-axis. As we have our points, that is going to be from 0 here. That's 1, 2. Okay, that's 3, 4, 5, and so on. 7, 8. So, okay, we can just add up the 9 at the end. Then as we saw, the y values were from the -4. So we're going to have -1, -2, -3. Then you must also indicate a -4. So on my case here, I did not put that space. We are not going to have that effect, but do not try that one in exam. You indicate everything as it is. The interval that you are given is the one that you're going to use. So in this case, it is just because I had gone through the coordinates that we are given, and so that we are not going to have an effect even if I leave that one. So no problem. So that was our Cartesian plan. This is our Cartesian plan with the information that we are given there. So the first part, out of this information, we are supposed to draw, and we are supposed to have this one as a clearly something that is clearly presented, right? We are supposed to have this one clearly presented. We have the coordinates, the vertices that we are given of quadrilateral A, B, C, D. And we have got the vertices, which is A, which is 3, 2. So let's start with A. That is 3 versus 2. As we just can see, guys, this is 3 and that is 2. So where these two meet, we are going to what? To mark a point. So that is our point A. So we are going to have this one as our point A. Then B, that was 4, 2. Okay, do the same thing. 4 versus 2. Gonna mark the point. That was our point B. Then the point C, which is 4, 3. So we have got 4 versus 3, which is going up. So that is 4 versus 3. We mark the point, which is C. And that's a quadrilateral. So that's 3, 4. The last one, which is D. So 3 versus 4. We are going to have the 3 here, then 4 that is on top. So that is 3 versus 4 here. So we're going to mark our point. That is the 4. It's actually at this. Let me have it properly here. So it is actually like on this line. Okay, so meaning to say that was going to be our point D. Okay, so we have got the vertices indicated. And from these vertices, what you're just going to do is to join using the ruler. So you must use the ruler there to join these points. That is, okay, let us say from A to B. Okay, just make sure you join properly. the points that you are given. All right, then we got also these two and also these two. Okay, so that was the condition of our question. We've got our quadrilateral A, B, C, D. So with this, the question now was draw quadrilateral A1, B1, C1, D1, the image. That is the most important part there. This is what? The image of quadrilateral A, B, C, D. And this is done under what? A translation with a translation vector of 3 minus 5. Remember, I talked about the translation, the determining of the translation vector. Translation vector TV is equal to the image minus what? The object. Meaning to say, if we are to have the image of A, we must take its object this side. So we must have translation vector, add to the object to determine or to have the image. Okay? So meaning to say, what you're going to do, guys, you're going to have these points, all these points taken into consideration. The first point, A, meaning to say the image of A, we are going to have translation vector, which is 3 minus 5. We add its object to obtain what? The image. So the object is the point A as it is the 3, 2. So that's 3, 2. You're going to add, that's obtaining the image. So 3 and 3, that's 6, minus 5 and 2. If you add, that was going to give us what? Negative 3. So that's the point A that we are having, the image of A, which is what? 6 minus 3. We have got the image. From this, we can have the image. The same thing if on these coordinates, guys, we're going to have the same thing if you are to have the point B, B1. So we're going to do the same thing. The translation vector, 3 minus 5. What are we going to add? The object of that B, which is 4, 2. All right, I didn't want to do it this way, but let me just finish. Okay, so that was going to be 3 and 4, which is 7, minus 5 and 2, which is what? Negative 3. So that's our image B1, 7 minus 3. Okay, so we have got the same thing for the point C. We have got, okay, we're gonna need its image. So the image of C, translation vector, 3, negative 5. Then we add the object C, which is what? 4, 3. Okay, so I'm gonna show you another way very soon. So that was going to be 7, negative 2. Okay, so this is 7, negative 2. The same thing with D. Okay, that's 3, 4. So translation vector plus that one. Okay, we are done on this one. So that's 3, negative 5 plus the point D, which is what? 3, 4. So as we've got our point D here, 3, 4, you write it as a vector. So that's 3, 4. So adding this, it was going to give us 6, negative what? Negative 1. Okay, so that is what actually we were going to have in this case, which can be written as a point 6, negative 1. So with these coordinates, what you're going to simply do is to mark them on the what? On the graph. Yeah. But we can also have this image by just understanding what this translation vector actually means. Let's go back to the understanding of the translation vector. So this is another way. Okay, you can have this way. You're done. You mark those points, you draw them, the image. Okay, let's go back to the understanding of a vector. I said a vector is a movement. A vector simply represents a movement. So this is 3, negative 5. Let me take it down. 3, negative 5. We are given a translation vector of what? 3, negative 5. And what I'm saying here is that A translation vector here is a movement, that is to be done. How? This movement tells us how we moved along the x-axis and along the y-axis. Remember, it was a point xy. Now it's just written as xy like this. This is now a movement. It's no longer a point. This represents a movement. You are moving from one point to another. So we are going to move in the x-axis, in the y-axis. So in the x, it's 3, which is a positive. So when you are in the positive for x, it means we are going to the left side. Remember, from the origin, positive values, we are going to the right side. We are going to the right side for positive values in x. For the negative values, you'll be going to the left. For the y values, if it is positive, it means you're going up. This is what for the y values. If it is negative, you're going down. That is the idea. So it is a movement that you are having from one point to another. So you must move completely this vector that you are given from each point, each. Okay, let's start with A. This is where our point A is. And according to scale, each box that we have represents 1. So meaning to say, as we are going to move in the X, we are going to be moving positive 3. Okay, gonna go to the right. Remember, X is positive. So we're gonna move 3 units to the right. But we're not supposed to end there. We are supposed to move again going down because y is negative. So you must move again going down 5 units. Then you mark the point. So let's start with A. So A, we're going to move 1, 2, 3. These are the 3 boxes according to scale. So we've moved in the X, going to the what? Going to the right. At that point, you're not supposed to stop. You're supposed to move 5 units going down. So we're going to move 1, 2, 3, 4, 5. So as we can see, where we are ending here, our end point, it's 6 versus what? -3. That is the point that you're supposed to mark, the 6 versus -3. This is the point that we are supposed to be working with as our image now. So that's how we play around with this. We can have it as a movement. A vector is simply a movement. So this is the image of what? The image of A6 minus what? 6 minus 3. So you can call it A1. So if we go back, is it the same? The one that we obtained by calculation, 6 minus 3, exactly the one. It means by calculation, you are correct. You're going to mark this point the same way, 6 minus 3. By movement, you are still going to obtain the same thing. Okay, let's prove with B. So for B, we must have the same answer as this one, 7 minus 3. Okay, let's see. That is our B. So remember our vector, 3 minus 5. So we're going to move to the right, then go down. So from B, let us move 1. Okay, so it's going to be 1, which is 1 box, 2, 3. Okay, so we have moved 3 going to the right in the X. Then in the Y, our main units, 5 units going down. So let's count 1, 2, 3, 4, 5. We are at this point, 7 and -3. So this is the point that you're going to mark. Okay, 7 versus what? -3. That's our point B1. Guys, these are whole numbers. 4 versus 2, you cannot have these points as 7 versus, now you have got a decimal what? It's 7 versus what? -3. The same B1 here. That we obtained by what? By calculation. 2 ways that you can answer this type of a question. You can't fail to lose questions like these ones, guys, for transformation. These are direct questions. You choose 2 ways. There are actually so many. Okay, the same thing for C. We're supposed to have this. Okay, let us just try to be quick. The point C, do the same thing, move in the X, 1, 2, 3. You have moved 3 units. Then how many units going down? 5 units. That is 1, 2, 3, 4, 5 at this point, which is at 7 what? 7 versus minus 2. So at 7 versus minus 2, we're going to mark our point as C1, which is the same thing as what we have here, 7 versus minus 2. The same thing on the point D1, which is the image. Let's see. From the point D, this time we are moving from the point D 3 units to the right. So that's 1, 2, 3. Then from there, 5 units going down. 1, 2, 3, 4, 5. We are going to end at 6 versus what? Minus 1. That is where we are going to end. We mark that point 6 versus what? Minus 1. That's our point D1. So as we can see, we could have obtained this by movement, not by calculation. So it's in your hands, this type of a question. All right. This one, it is actually in your hands. You work it out the way that you understand, by calculation, by movement. That is the advantage of transformation, guys. Actually, transformation, almost each and every question, you can have it by calculation. You can have it by a graphical presentation, the way that you understand that transformation. That is how you can have it. So that is it. So we have got the object and its image. Okay, let's figure out, let's see the other question. Let's see what we have. But for this one, guys, as we can see, it was in your hands. So these are the typical questions that you must expect on your transformation. Another part of the question, which is C item 1, draw the quadrilateral that is A2, B2, whatever that you're given with these vertices. Okay, so that was a straightforward question. 1.5 versus 1, which is A2. So 1.5, that is in between. So that is 1.5 in between 1 and 2. Okay, so that is going to be versus 1. So we can simply go to the 1 on the Y there, versus 1. Then 1.5, we must count 5 boxes. So that's approximately 1, 2, 3, 4, 5, somewhere there. So it was going to be somewhere there. So this is going to be our point A2. So we are given the other one, B, which is what? 2, 1. So 2 versus 1. This one was direct. You can simply mark this one. So that's our B2. Okay, then another point that was C2 versus 1.5. 1.5 is just like 1.5. So 2 in the X and 1.5, just gonna count 5 boxes. 1, 2, 3, 4, 5, somewhere there. So that's our point C2. Okay, then D2, 1.5 versus 2. Okay, we had the 1.5 before this one, but it must be versus 2 this time. So you simply have to go up to 2. So that was going to be our point D2. Okay, so that was it. With these vertices, we can join them and have our quadrilateral A2, B2, C2, D2 as we are given it. So that is how we can have our questions for transformation. As we can see, transformation, there are just some 3 marks. Just imagine having this diagram, a mark for just doing this. Then to further extend this question, they want us now to describe fully the single transformation that maps quadrilateral A, B, C, D onto A2, B2, C, D2. Describe. So transformation is an easy thing, guys. An easy topic, like I said before, for those who watch the videos, I explained about transformation. Each and every transformation, by looking into it, you can tell the answers that you must have. In this case, we are being asked to describe. And they actually mentioned that it is a single transformation, the single here. In one question, we do not have two transformations that we answer. It is a rotation from the same question. It is a reflection from the same question. It is an enlargement from the same question. It is a shear. No. Each transformation has got its own properties. So that's why I advised you guys to watch those videos, each transformation as it is. Understand what is it that you're working with on a rotation. So anyways, without wasting time, let us see. We can figure out that the isometries in this case, they are actually out. Okay? Considering the isometries in this case. When I'm talking about the isometries, I'm talking about those transformation, rotation, the reflection, and the translation. These three, they are totally out. They are under isometries where the object and the image are exactly the same in terms of the size that we see. The position can change, but the size, the shape, the way that we see it is supposed to remain as it is. But as you can see, guys, this image has changed. It is smaller compared to the object. The image is smaller. So meaning to say the three transformations are out. So we are left with what? We are left with enlargement. All right. We are also left with the shear. We are also left with the stretch. Okay. So of these, stretch and shear are going to remain. I mean, stretch and enlargement, but this shear is going to go. Shear. Why? The shear, we know, guys, the way that it affects in terms of the shape. You won't see the shape being smaller like this. The same thing that happens with the stretch. Yes, we can have a shape being affected in terms of the size because the stretch factor can be a fraction. So where a stretch is, it means an enlargement is also there. Okay? The moment you suspect that it's an enlargement, also think of a stretch. These two, they go hand in hand. Okay? So the shears on its own, you're going to see the shape may be affected in terms of the way that it looked like. It won't have the same shape as it is. A stretch can maintain the shape. It can get smaller. Okay? Because it is one side that is being affected in terms of the stretch. One side is affected, another one affected. If we check on the enlargement, it has got the same scale factor, this one. The scale factor has to be same. The way that you enlarge the sides, that is what I refer as the scale factor. The way you enlarge the sides. So you can test that one by looking into these sides to say, from our object, all right, this is our object. From our object here to the image, it is supposed to be image over the object. So you can test by the corresponding sides. When I'm saying corresponding sides, I mean if I take this side, B2, C2, this one, B2, C2. From B2 to C2, this side. It is how many units? It corresponds with BC. How many units? That is the condition. So the scale factor, you take what is from the image side, you divide to what is on the object side. So what is on the image, B2, C2, this one, B2, C2. If we just take for an example, B2, C2 over BC. From B2 to C2, how many units? Remember, this is half of a box. The whole box represents 1 unit. So half of that one is what? 0.5. So it's 0.5 over BC. As we are going up, that's 1. So you're going to see that the scale factor is going to be 0.5. But we are not done because it is supposed to be the same. Here is a test that you're supposed to do. So you do the same thing from A2, B2 to what? Corresponding to AB. They must correspond. A2, B2, AB. So if we are to check that one, A2, B2 image over what? Over object. A2, B2, that's 0,5. The object is 1. So it was going to give us the same answer, 0,5. Check here again, A2 to D2, that one. If you take A2, D2 over AD, from A2 to D2, how many units? 1 over what? AD, 1, 2, 2 units. As we can see, it's giving us the same answer. 0,5 is same as what? 1 over 2. This one, by just looking here by sight here, you just need your sight to see that this line here enters in this one 2 times. So we have got the same thing. So it means this was an enlargement. We've got the same scale factor, image over object, the corresponding image line to the corresponding object line. It is giving us the same thing, which is what? Which is 0,5. It is giving us the same thing. So it means we can conclude that it is what? An enlargement. Also, if you are worried about that, say, okay, maybe the way I'm finding my scale factor is wrong, you can do this. This is exam. Before you test for stretch, start always with enlargement. When enlargement fails, you know that the answer is stretch. Yes, there are ways that you're gonna check for that stretch to be actually sure about that, to say, okay, this is truly a stretch. There are ways I talked about that. Watch those videos. But wherever you think that the answer is a stretch or it's enlargement, because these two, they go hand in hand. Just like the isometries, these three, they go hand in hand. So wherever that you think it's enlargement, always think of a stretch. Never leave a stretch out. So how now do I conclude? Like I said, you are supposed to start by what? Observing the enlargement, because it is the easier one. This is another way. You join the points, object to the image, extending them. Take note what I'm saying. Extending. What do I mean? From A2, from A here, as I join to A2, I must extend the line. I'm not just supposed to join from A to A2, from D to D2 like this, from C to C2, from B to B2. No. I'm supposed to extend whenever I suspect for that enlargement, I extend. So let's join. That's A. Okay, so A here to A2, but we must extend that line. Okay, let's try to extend, because those these lines that we are actually working with, they are going to meet at a certain point. So that is why you're supposed to extend them. Okay, so we joined from A to A2, its image. We do the same thing, B to B2, extending those lines, all right? So this is B to B2, extend the lines, okay? So that is what we're going to have here. Then the same thing, the C to C2, okay? C here to C2. So this is something that you can even check by just using your ruler, guys. Because remember, you are testing to say, is it enlargement or what? So instead of you trying to have these lines, then you start again to erase those. You can test by, you put a ruler like this, and you see that, okay, these lines, they meet at a certain point. Once that happens like this, two of them, to say they are going to meet at a certain point like this, that one, it is enlargement. Once you are suspecting this enlargement or a stretch does not do this. It doesn't do this. This one, it is for an enlargement. You don't need to join all of them by just seeing these two. Here we can see even these three, from B2 to this one, 3 of them. They all meet at what? At the origin. Even if we are to join the last one from D to D2, we're going to see that it was going to do the same thing, meet at the origin. This is the case. So here we are satisfied that it is truly an enlargement. A stretch does not operate like this. It's totally different. So what did I say, guys? You test first for what? An enlargement. If these properties that I explained fails, that is an automatic stretch. That one becomes a stretch. Where enlargement fails, the answer is for stretch. Where enlargement fails, the answer is for stretch. That is how you answer these questions. You don't just answer, say, okay, this one is enlargement. One day you find out it's a stretch, a two-way stretch. Okay, in that manner, because here when I say a stretch, it will be like I'm talking about the one way. A stretch, remember, it's one way, a two-way. So the enlargement there, the stretch that I'm talking about is what? A two-way stretch. The shear that we canceled, it goes hand in hand with a one-way stretch. Where you think that the answer is a shear, also think of a one-way stretch, because it stretches only one way, in one way. So the way that it does, it is similar to a shear in some other properties. Know the property of each, guys, each transformation. So here we are satisfied that it is what? An enlargement. So we can have our description now. So we are going to describe it is an enlargement. It is an enlargement. That is the only part that you are supposed to mention, not to tell us that I saw this is that it is enlargement because I joined the points, these ones. When I joined them, you don't discuss about that. Don't even write it. Answer the question. It is enlargement. Full stop. The next thing, on the properties, it is the center. So the center of enlargement, it's what? 0, 0. About the origin. So you can write center 0, 0 or center about the origin. Then the scale factor at the end. So the scale factor, we already calculated this when I was taking the image line corresponding to the object, the image to the object, the image to the object. We talked about that and we obtained what? 0.5. So the scale factor, we obtained this. We can even use this one, A2, B2 over what? AB. Remember, it gave us what? 0.5 over 1, which is what? 0.5. So our scale factor is 0.5 or 1 over 2 as a fraction. So that was it. And as a positive, the way we calculated, we saw there were positive values. And also, according to this one, if you check this way that we have it, the object and the image are on the same side. So the scale factor becomes what? A positive value. If the center is somewhere here, the object is on another side, the image on the other side, there the scale factor becomes a negative. But even by calculation, you can see that you'll be getting what? Negative values. Here you can see that we were getting positive. As we talk about A2, B2 over AB, A2, B2, A2, B2 here. We are going where? To the right. So it's positive 0.5. AB, we are going to the what? To the right. So it's positive 1. It's a positive value. Do this to anyone. This B, you are going up. This one, you're also going up. Positive over positive. Your answer is positive. This one, you're going up. This one, you're going up. Positive over positive. According to the direction that you are moving from A to this B, from A to B. How is it presented on your graph? Where are you going, to the left or to the right? The scale factor can be seen that it is a positive or not, or a negative. So guys, transformation is in your hands, guys. You cannot fail you cannot actually lose marks on a transformation if you're actually done transformation using our videos. Guys, that one is impossible. For those who have done transformation with our videos, you know that you have to totalize this question, because you can prove each and every part. You can check to say this one is wrong, This one is correct. And also, to check or to verify here, another way after this, because you have already told us that this is enlargement what? So maybe you've got time in exam. You want to prove that truly what I'm saying here is correct. Remember, if we take the matrix for enlargement, matrix times object, we must get what? The image. If the center is 0, 0 like this. So meaning to say, with the scale factor of 0,5, our matrix was going to be 0,5, 0, 0, 0,5 like this. You take the coordinates of the object, which is A, B, C, D. You take them, you multiply them by this one. You are going to see that the answers that you obtain are exactly the ones that are here on your image. This is to show you that this scale factor is actually the right scale factor. Anyways, that one is for proof, for those who want to prove to see if it is correct or not. Okay. So on D, we are given to draw the image of quadrilateral A, B, C, D under a 90-degree clockwise rotation. Okay. About, we are given the center. Okay. So label that one A3, whatever that you're given there. Okay. No problem. So also for this one, it is just because the issue of the instruments, guys, but we can have this one again graphically or by calculation. So for those ones who are going to have it on a graphical way, the first thing was to mark the center. You mark where the center is 1, 1. So 1, 1 is our center, 1 versus 1 here. This is our center. So what is the object? What is the concept here of the object to the center? We understand when the object is joined to the center. Since we are given that it is a 90-degree clockwise, we are supposed to have a 90-degree from that center going to the image. We must have a 90-degree in between. So you can do that one as a test. You have it on the diagram. So this one I'm just going to show you on one point. Then you prove, guys, with other, you do with other points. Okay, so let me explain what I'm trying to say here. So this is what you're going to do. You take this point from A. Okay, you want to have the image of A, so you must join A to the what? To the center. Remember, our center is 1, 1. So you join that one from A to the center. Then you must measure 90 degrees in a clockwise direction from this side. 90 degrees this way, clockwise, the way that the clock moves. So meaning to say this one, you're going to need the instruments, but it is not bad. As long as you understand what you're doing. Okay, so let me just quickly have this one. Okay, so here. Okay, let's take this one. Okay, so I'm just going to explain here with this. So this is the line that we need here. We need this line, remember, from A to the center. This is the line that we are focusing on. So let us place our protractor along that line and see where the 90 degrees is. Remember, it is a 90 degrees in a clockwise direction. So we must cover this line, that light, the line that is a little bit light there. So if we cover it like this, okay, and you measure your 90 degrees, remember they said clockwise, meaning to say we are going this way. That is clockwise, this direction. This is the movement of a clock. So meaning to say our 90 degrees, if we put it on this line, just according to your graph, just have it according to your graph. You are going to see that, all right? So this is approximately, it's just going to be somewhere there. So the 90 degrees, somewhere here, you mark it, the 90 degrees. So it's only that, okay? So here it was going to be a continuous line, something like that. Then you measure the distance that is from A to the center, it is supposed to be the same distance from the center to its image. So as we can see, the point that was going to correspond was going to be here at 2 minus 1. So that's the image A1. Just like that. So we can have these B, also C. Look, guys, it's going to be a lot. And also, according to your graph as well, guys, you can see a lot of things will be on your graph. There'll be a lot of things on your graph. So you can avoid it by what? By calculation. So the question is, how are we going to apply the calculation? We have got the center. So we are going to take our center. Let me have it this side. So that was it for this method. So you finish, do this A, B, C, D, each point using the same way that I presented. Okay. So the other way that we could have just applied was to use the matrix method. Whenever we are given a center which is not 0, 0, get rid of that center first before the use of the matrix. A 90 degrees clockwise rotation, remember your matrices, that was going to give us 0, negative 1, 1, 0. So the matrix is there. The matrix whatever it. But there is a center which is not aligning to what we need. So we must get rid of that center from what? From the object. So we're going to take our A, B, C, D, which is our object. We subtract the center, which is 1, 1. So we must get rid of the center. So the object is the one that we are given, guys. Those coordinates A, B, C, D, we were given those ones from the very first information. So just write them, guys, as what? As coordinates, which is A is 3, 2. B was 4, 2, remember? C was 4, 3. And D was what? 3, 4. So you're going to subtract the center. So in this case, don't take it the way that you operate with your matrices, because you know that this is totally impossible. Here we are subtracting the center from A, we are subtracting the center from B, the center from C, the center from D. That is the way that we are operating. These are points differently, but we just combined them to be one. So do not take that matrix way and you say this is impossible. No. So that's 3 minus 1, which is 2. 4 minus 1, which is 3. 4 minus 1, again 3. 3 minus 1, which is 2. All right. So you do the same thing. 2 minus 1, which is 1. 2 minus 1, which is 1. 3 minus 1, which is 2. 4 minus 1, which is what? 3. So after subtracting the center, now the matrix can be used because these coordinates, they are now at 0, 0. We have removed the center. So it's like we have taken them to the origin by doing this so that the matrix can be used. Remember, matrix times object gives us the image, but the image must be at 0, 0 so that the center can be added. So that's the condition now. So let's take our matrix, guys. 0, negative 1, 1, 0 like this times what? The object, which is at what? At 0, 0, which is the 2, 1, 3, 1, 3, 2, 2, 3. So let's multiply row by column. So as we have this multiplication, the row by the column, row by, and so on. So you're going to see, guys, 0 times 2, this is 1 times 1. So the 0 is going to do the same thing. 0 times 3, 1 times 1. So, guys, why wasting this time of us multiplying the 0 times 2? Let us just take 1 times 1, which is 1. 1 times 1, which is 1. 1 times 2, which is 2. 1 times 3, which is 3. The same thing here, this row and the column. The minus 1 was going to multiply this. 0 was going to multiply this. minus 1 this, and 0 multiplies this. So as you can see, guys, it is easier for us to just take minus 1. It multiplies everything on top since the other side is affected by 0. So minus 1 times 2, negative 2 times 3 times 3 times 2, just like that. I'm not saying adding that 0, guys, is wrong. No. So we have the image, like I said, but this image that we are having here, it is the image which corresponds exactly at 0, 0. It is at the origin, this one. Remember, we subtracted, we removed that center. But as we need the image which corresponds at the center of 1, 1. So we must get that center back. Remember, we removed it. So we must add back the center. Do not forget this. Add back the center. So the center, as it is, we are going to add it. That was 1, 1. So we take this as it is, 1 minus 2, 1 minus 3, 2 minus 3, 3 minus 2. Then we add our center. So this is what I was saying, guys, before, to say that do not consider the way that you add your matrices. Yes, just this one is added to this. This is added to this. So we take it that way, you won't go wrong. So 1 plus 1, that was going to be 2, 2, 2 plus 1, which is 3, 3 plus 1, there, that was 4. Negative 2 and 1, that's negative 1. Negative 3 and 1, that's negative 2. Negative 3 and 1, negative 2, negative 1. So this is what we're going to have. And that's our image now. The one that we are supposed to have as A3, B3, C3, D3. It is now the image which is at the given center of 1, 1 as we are having it before. So those are the coordinates that you are going to mark, guys. A3, which is what? 2 minus 1, followed by B3, which is 2 minus 2, followed by C3, which is 3 minus 2. And the last one, which is what? Which is D3, which is what? 4 minus 1. So these are the ones that you are going to mark on the graph. So let us have our points. So as we have got our points in this case, you're going to see that, okay, A3, that is 2, negative 1. So we've got 2, negative 1 here. That's our A3. Okay. Then B3, 2, negative 2. That's 2 versus a negative 2 here. That's B3. Okay. Then 3, negative 2 on what? C3. 3, negative 2 here. That's our C3. Then we also have D3, which is 4, negative 1. So that's 4 versus negative 1. This is our D3. So that was the quadrilateral that we were going to have at the end, and simply join the corresponding points. And by doing that, guys, we are having a complete quadrilateral in this case. So this is how these questions are just supposed to be attempted, as you just need time, focus on the question, understand your transformations, understand your transformations. So this is, yeah, something like this. We're going to have something like this at the end. Just make sure that everything is properly presented. Then another question that we had, guys, be very careful with these typical questions here. Be very careful. On E, we are given, write down a matrix representing a stretch parallel to the x-axis. Guys, do not just answer these questions. It is a stretch that you're dealing with. So what is the case of being parallel to something? Parallel to the x-axis. There you are focusing with the one stretch at a time. One. We can be given, it is parallel to the x-axis with a stretch vector of, and they give us another one parallel to the y-axis and a stretch vector. That one, it becomes a two-way stretch. We had a part which was parallel to the x. We had a part which was parallel to the y-axis. So this one, they just ended on the x. So it is not a two-way stretch. It is a one-way stretch that we are dealing with. A one-way stretch. Remember, from the two-way stretch matrix, the hook, this one that I talked about, when it is a one-way stretch, it means one is affected. On the first one, we can have it like this. Y-axis invariant. From the same hook that we had, we can have one part affected, which is of the x, this one as 1, 0. Guys, as long we are talking about a stretch, these are the two formats of the matrices that we are going to have. As long it is a one-way stretch, we are not going to have any other matrix, any other presentation here. No. Know your matrices, guys. Know your matrices. Know your matrices for transformation. A two-way stretch, that is the one that will be a hook like this. This is now a two-way stretch, this one. The H and the K, they simply tell us these are different stretch vectors. There's a stretch vector here, there's a stretch vector here, which is opposed to a what? An enlargement, the Cook, this one, the matrix Cook enlargement. This K represents, it is the same scale factor. That is the only difference that we can see. So if you know the matrix for a two-way stretch, then for a one-way stretch must be easier, guys, to know. Revise, guys. Revise these things. As an individual, don't wait. Revise. Okay? So let's answer now our question. The question, yes, we know the matrix can be one of these, but which one? They say the parallel to the x-axis. Parallel to the x-axis. What does it mean? A stretch parallel to the... Okay, let me go this. You understand me very soon. This is the x-axis. This is the y-axis. If a line is parallel to the x-axis, that line it is of y is equal to something. At this point of the origin, the x-axis as it is the line of y is equal to 0. So any other line that is parallel to the x-axis must be of y is equal to 1, y is equal to 2, y is equal to 3, y is equal to 4, y is equal to -1. All these lines, they are parallel to the x-axis. So meaning to say, it is the y value that they are talking about, which is invariant, the y-axis. The y part is invariant. They are simply saying it is having the y-axis as the invariant line. What is supposed to happen? Because our lines here, they are parallel to the x. So where the line was supposed to be here, where the point was here for y, it was supposed to be what? 0, 1. Remember here, the point that we use when we are creating our matrices. So we are going to have parallel like that. This is the line that is not affected. It is parallel to the what? To the x, the 0, 1. So meaning to say, this is the one that we want. The stretch factor of, that is the h. So the matrix was going to be, the stretch vector is what? Is 3. So that's 3, 0, 0, 1. This is the matrix. If it was parallel to the y-axis, you're going to take this one. So this one is what? Parallel to the y-axis. Stretch parallel to the what? To the y-axis, this one. Parallel to the y-axis. This one, parallel to the x-axis. So understand this. Parallel to the x-axis. To the x-axis. And I also, guys, mentioned about this transformation. It is the way that we are also being taught our transformation. We are being taught this transformation by people that also need to be taught that transformation again. Then you listen to that person as a teacher. So it becomes a challenge even in class for you to understand this topic. But as I said before, this topic is there. I presented everything that you need to know about transformation from the first class up to the last one. So make sure that you go through the playlist for that transformation. Understand what you're doing. Even questions, ask questions. You have the right as a student to ask your teacher a question. Why are you doing it like this? Let them explain. And also put your explanation on the table also. Do it in a nice way. Do it in a nice way. The teacher is not always correct. We are in class, the teacher is saying this, you are all following. Yes, 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 no. You have a reasoning to what is being said. You have a reasoning to what is being taught. It is not a follow-up. Learning is not a follow-up. You have a reasoning also in terms of your understanding on that topic. So this is it, guys. Let us not be limited in terms of our educational expansion, especially in our revisions. You're at school, the teacher is telling you, I don't teach this topic. So the reason why I keep on emphasizing on these videos on transformation is because a lot of us, or a lot of you guys, you are facing that. You're in class, the teacher even does not even go through that topic. And even if ask questions, they'll be running away from those questions. Sit down with your teacher, ask proper things. Here, this thing is not, I think it's supposed to be like this. Talk. It's supposed to be like that. It's learning. It's part of learning. It's part of learning, guys. Do not hesitate to ask. Even in the group, it's only that maybe sometimes I might not be available, but if you think there's something that I explained in another way that you do not understand, yes, ask me, guys. I will be able to come back and answer that question to say it was supposed to be like this, or this explanation can be like this, or this question can be answered this way or this way, where you are not satisfied. We are there for that, to make sure that we have got the light in what we are doing. So let's keep on revising in as much as we can.